Good morning, guys. This is Mr. Middleton. Today we're going to talk about more multiplication properties of exponents. By the end of this lesson, we should be able to raise a power to a power, understand that rule, and raise a product to a power. We're going to start off by looking at just a couple examples to kind of prove our rule, and then, or at least find our rule, and then use it. So here we have 5 to the 6th power squared. And we're going to treat this just like we would any square number. What does squaring a number mean? Well, it means multiplying it by itself twice. In this case, we're multiplying 5 to the 6th by itself. 5 to the 6th times 5 to the 6th. And from our last lesson, we should see that means we add these two numbers together. So that equals 5 to the 6th plus 6, which is 5 to the 12th. Okay. And you can do that for each of these values. We have 3 to the 4th. Do that 3 times 3 to the 4th times 3 to the 4th times 3 to the 4th. Right, it's cubed. Add those together for 8, 12. Should give us 3 to the 12th. Alright. Do it with a variable as our base, a cubed or a to the 3rd power squared, a cubed squared. So that means a to the 3rd times itself twice. A 3 plus 3, a to the 6th. Okay, we can do g to the 7th times g to the 7th times g to the 7th times g to the 7th. Okay, 7, 14, 21, 28. G to the 7th to the 4th power is g to the 28th power. Okay. So if you haven't seen the pattern here, take a second, think about what's happening. A lot easier to figure it out on your own, or at least the sticks would be a little bit longer. Okay. So here's the pattern. Here's how this is the rule for raising a power to a power. For every non-zero number, a, and integers m and n, just mathy terms. When you raise a power to a power, a to the m to the n, what you're going to do is you're going to multiply the exponents. That new power is the product of those exponents. Okay. And so we don't have to do this each time that we see that happening. We can just say, oh, we're raising a power to a power, let's multiply. 5 to the 4 times 2, 5 to the 8th. N squared times 5, or to the 5th, give us n to the 10th. And this is where it really saves us time. I don't have to write n squared 5 times like I had to do it for g up there. Okay. Alright, so here are a couple examples. If you want to pause the video and try them on your own, do that. Okay, so we have x cubed to the 6th. That's going to give me x 3 times 6, x to the 18th. Should be our answer there. And here we have c to the 5th times c cubed to the negative 2nd. Okay. So fc to the 5th, nothing changes there. That exponent, even though it's not written there, is actually 1. C cubed to the negative 2nd gives me c to the 6th. So here, I'm taking my next step horizontally as I've been doing. C to the 5th, I just multiplied that and got it out of its parentheses. 3 to the negative 2nd will give us negative 6. When I multiply these together, it means I'm adding the exponents. So that gives me c to the negative 1. Okay. Remember, our final answer can't have a negative exponent in it, and so I'm going to move that to the denominator so that I have positive exponents. So I could say 1 over c to the 1, and that would be the same as me saying 1 over c. Okay. Alright. This goes for polynomials, or is it monomial? Let's say monomial. This goes for monomials as well. So our products, things that are already being multiplied together, that rule stays the same. But what happens now is instead of just multiplying like the exponent, just adding it to the end, what we're going to do is we're going to now distribute the exponent to each exponent in here. Okay? And just a reminder that when a number does not have an exponent over it, a written exponent over it, then we know that that exponent is 1. Okay? And so that's what happens here. See, we have a product in here. A is multiplying B. Let's look at an example. So here we have 3x to the 4th. Okay, again, this is a product. It's not just one number. Each of these numbers has a variable over it. 3 has this variable 1. X has this variable 1. It's assumed, but this is really important now to remember to use that. So we have 3 times 4. X to the 4th. Okay, so we can keep it like this, 3 to the 4th, x to the 4th, or we can simplify that, and that gives us 3, 9, 27, 81. So either of these answers, 81, x to the 4th, or 3 to the 4th, x to the 4th. Okay. And if you're confused about why that happens at all, we can have it down here and say 3x times 3x times 3x times 3x. And so you see it's 3x to the 4th, 3x times itself 4 times. 3 times 3 is 9, times 3 is 27, times 3 is 81. X to the 2nd, x to the 3rd, x to the 4th. Okay. So it's a little bit faster just to be able to distribute this power to both terms there, rather than writing all your 3x's down. Alright, let's look at some examples. You can pause it and try on your own. Give you a second to do that. So I get started, ready to go do these. Alright, so we have 2 to the 4th, x to the 8th. 2 to the 4th, x to the 8th, what is that? I can write that as 16, x to the 8th. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? I want to distribute this to both terms here. Have 4 to the negative 2nd power, g to the negative 10th power. Okay, both of these are negative, so I want to move them down. My final answer can't have negative exponents. I'm going to move these both down to the denominator. When both these leave, my numerator is now 1. Okay, so I have 4 squared, g to the 10th. So 1 over 4 squared, g to the 10th. And I'll just change this because it's the number that I can manage to change. Okay, 4 squared is 16, g to the 10th. If it's a number that's really high, like let's say if it's at 4 to the 8th power, it's not really something I can know right off the top of my head, then it's okay to leave it there. That's 4 to the 8th. But with numbers like this that you can convert to standard form, go ahead and do that. Alright, we'll distribute this one. We got distribute. Okay, so I have 3 to the 4th times t to the, well, it's still 0. So t to the 0, that's just 1. Okay, so it's like 3 to the 4th times 1. Okay, I don't need to write that anymore. And so that'll be 27, 81, 81. It's just the answer. Alright. Final example here. Gave myself some space to do this. I don't know if I need very much, but we have x to the negative 2nd power square. Do that. That gives me x to the negative 4th times 3 to the 4th, x to the 4th, y to the 8th. 4 times 2 is 8. Okay. And so now to simplify this all the way, I want to make sure that my bases, my like bases are all together, and I want to make this just one product. So I'm going to see that I have like bases here. I have x to the negative fourth times x to the fourth. That gives me 3 to the fourth. These two added together give me x to the 0 power. Okay, I'm going to write that here just so we can see that step. Y to the 8th. Again, I'm multiplying all these. X to the 0 power is just 1. Okay, so I'm multiplying by 1. That means I really don't need to write it. So 3 to the 4th, 81, y to the 8th. Okay, so multiplying a power to a power, multiplying a product to a power, you see that what's happening here is we are distributing our exponent to the product or the number inside. Important to remember that we don't want a negative exponent in our final answer. Also important to remember that if there is no exponent written over the number, it's a 1 there. Okay, a lot of people mess up and think that's 0 because it's not written, but it's 1. All right. See you tomorrow.